Alright, here's one more I can leave you with. And sometimes you have to combine inequalities. So there'll be like parts and previous parts and things like that. Here's an example of that. And remember, like I said, it's not always going to tell you what method you should use. So you're just going to have to try and work out sometimes. Are we doing LHS minus RHS? Do we use known results? What other options do we have? Have a look at this one. What is that? Example 6. Prove that something is bigger than or equal to something. Try LHS minus RHS, right? That's always something that you can do, okay? And then let's see what happens, right? So x on y plus y on x minus 2. So I should say LHS minus RHS here. Any thoughts about where we can go? Probably should have common denominators, I guess. So what are we going to get? We'll get x squared plus y squared on xy. What is this guy? Can we put him under the common denominator? Yeah, what would that be?
2xy.
Yeah, cool. And hang on, this is familiar. So you just have to see how important these perfect squares are, right? So x squared plus y x squared minus 2xy plus y squared all over xy. Just put it under one fraction. And so this perfect square, a bit easier to see than the other ones. That's just x minus y all squared, all of xy. What about the xy? Well, the xy is always greater than 0, right? Yeah, so that's always greater than or equal to 0, since xy is greater than 0. Yep. So not too bad with that first part. Now, hence, this is where things get interesting. We need to prove this. I haven't tried LHS minus RHS for this one. What I have done is I've done our favorite little method. Yes, this beat the HSC Extension 2 paper with this one simple trick. So we start off, we'll work backwards for a bit. We'll see we have 1 on x plus 1 on y greater than or equal to 4 on x plus y. Okay, so far so good. And what I go from here is I'm thinking, same idea. Should we put things under a common fraction? Well, it's going to get pretty messy. So what I'm going to do is I want to think about known results I can start with. So I want to get rid of this fraction first. I'm going to multiply both sides by x plus y. And I'm actually going to expand here. So usually we don't do that, but I want to expand here because I want to think about how I can use this known result here, right? Because remember, it's a hence. And I have to combine these inequalities. How can I incorporate this into it? That's basically what I'm looking for at this point. And I can't see it here right now, but if you expand, something interesting happens, right? If I expand, what do you get here? Use your FOIL strat, right? So you got 1 plus inside, x on y, plus the outside, y on x, hang on a minute, this looks familiar, plus y on times 1 on y, so that's just 1. That's greater than or equal to 4. So this part, what do you know? Yeah, what is it? That's from over? Yeah, right, that's greater than or equal to 2. Yeah? And if you put that in, you know, so 1 plus 2 plus 1, greater than or equal to 4. In fact, it's equal to 4, right?
How do you write that?
How do you write that? So, here's where we do part B and we cheat.
Greater than or equal 4, but it's greater than or equal to 4.
But that's big brain math right there, right? So here's what we do. We do a consider expression now, yeah? Okay, so here's our consider expression.
That was the working backwards.
Yeah, so we consider. Now this time I don't know what it's going to be equal to, but I want to consider this expression here. Yeah? I'm going to consider this expression. The second last line one. Because I don't want to start with 4 greater than or equal to 4. That's not very useful, right? So we'll start with this one. 1 on x plus 1 on y, x plus y. This is what I'm going to start with. You got that down for me?
Jotting. Oh, yeah, don't. It's all good.
Yeah.
Because I was going to say, usually if we multiply like variables, you have to do it squared, but we know that x and y is greater than 0. So that's fine.
Oh, you mean for this inequality? Yeah, sorry, you're right. I should have mentioned that. Yeah. So these are all positive, so that's fine. So again, let's do this now. So I know that this is equal to, so this is a statement, right? This is not like a proof as of yet. But if I'm making a statement, I can create equalities or inequalities. Yeah, it's a bit different to assuming something's true than working with it. So this is just a statement for sure. Okay, so when you expand it, we know what we get. We end up with this guy over here. So I'm going to get 1 plus y on x plus, oh, sorry, other way. 1 plus x on y plus y on x plus 1. Yeah? And then from the previous part, I can say that this statement here, right? This statement here is actually greater than or equal to 1 plus 2 plus 1. Why can I say that? Why could I have to change it to greater than or equal to? Right, because this here is greater than or equal to 2. Yeah, so that's a logical statement, and then so that's equal to 4. So at the moment, you have a statement here. This, you should probably say from part A, right? From part A. So at the moment, this is a statement. The statement is that this is bigger than or equal to 4. Would you guys agree? Right? So you've created a statement here. You've created the inequality. You've started off with this algebraic expression. You've done some manipulation, and you've used the previous part to create this inequality here. And the reason why I changed this to inequality is because, yeah, these two are the same, right? So here's the inequality we've created. We've created this one here. So 1 on x plus 1 on y multiplied by x plus y is greater than or equal to 4. Would you guys agree this is true right now? Right? Because I've started with this statement and I've created my own inequality. I've gone from the next step here. I've used this previous part. This has been proven already. So you're allowed to use that. And this is the inequality we create. Why is that useful? Well, because look at what you were trying to prove. You were trying to prove that 1 on x plus 1 on y is greater than or equal to 4 on x plus y. So it's just one step I need to do here. Because I know that x and y are both greater than 0, if you just divide both sides by that, what do you get? Exactly right. Okay, so you can see how I mean like algebraic inequalities is a tricky topic because there's so many different ways you can do it. There's so many kind of results we have to consider. But the more of these we do, the more of them we expose ourselves to, I guess, yeah, the more confident we'll come with them, just like with any other skill as well.